Hello students, this lecture will be on correlation analysis. So, we will disclose question about correlation meaning and have some samples on Pearson correlation coefficient and Spearman's rank correlation coefficient. So, what does the correlation mean? Often we have some parameters and we have to understand if there are any dependence one from another. So we make sketch and place our values on this. That will be x, then will be y or Greek y. So then we place our values and then we draw the line always and trying to place it more closer to these points of our values. So we have some of this, and this is tangent of this value. It's positive dependence. It may be like that, negative. So if we have points like that. And if there are no any, we'll have such line on tangent node is will parallel to our y or y x. So let's go to examples and see how it works. So this is formula for calculating our Pearson correlation coefficient, and then the Chadwick scale, how we interpret our result. So, as you can see, the more value up to 1 of Pearson correlation, the more strong dependence of one of your parameter on another. So, in this example, we want to know if there are any dependence between aggression and a few of persons. So we have two samples and we have the two meanings of these two parameters that we measured, and we want to know if there are any correlation by Pearson. So we have to make some calculated. I prefer to make it in Excel, but you can use SPSS or R or test statistic, any program you want. So that's why that is an example. We have the first 3 strokes always. So and we use how to do this, and we have the means of these two samples, and then we go to correlation coefficient. In numerator we have this, and in denominator we have what that is. So if we place here as you can see. and then we refers to our Chadwick scale and see that there are negative or weak correlations between these two parameters. Spearman's rank correlation coefficient is used when we don't have parameter in digits and we have them in ranks. So we place it one after other, and this is the formula. As you see, this is not P but Greek rho, and we calculated by the difference between the two ranks of each observation placed by each other. I'll explain it later on example, and n as usual is the number of observations. If we then try to calculate the level of significance, then I'll remind you that the degrees of freedom is the size of sample n minus 1. So here are our ranks or parameters of x and y, and then we calculate our Spearman rank correlation. In this table in detail you can see it later, and for more time to pore over it and to investigate it. So after the calculation of Spearman's coefficient, we see that it's 0.98. It's very close to 1, so we have strong correlation between our ranks and our two samples, and it's very clear. Thank you for attention. See you on next lecture. Goodbye.